I'm Nathal from Microsoft and I welcome you all to Midas SOILWORKS training today. Today we are going to have a training on the foundation module of Midas SOILWORKS and we are going to learn about the horizontal stability check by PY analysis. But before I do the actual modeling in Midas SOILWORKS, let me talk about the different models that we are going to generate today. So as you can see on your screen, we are going to generate two different pile configuration. So these are the two different pile configurations that I'm going to model, and we are going to perform analysis on these two different pile configurations, and we will obtain the results for both of them. And finally we are going to choose the footing which is optimal for our design. You can see that we have four different layers in the ground. We have the alluvial layer, the weathered soil layer, the weathered rock layer, and the soft rock layer. So let us start the modeling in Midas SOILWORKS. So first of all, I'm gonna open Midas SOILWORKS. So whenever you open Midas SOILWORKS, you will see that a project manager window appears, and here you can select any type of module that you want to use in Midas SOILWORKS from the list of 6 different modules. So I'm gonna select the foundation module because we have to work on footings. After you select the foundation module, you can select the unit system. If you want to define your own unit system, you can go to user defined, where you can select the unit system for force, length, and time. If you want to define the unit system from the predefined unit system list like SI, CGS, or FPS, you can go ahead and select the type of unit system you want. For this tutorial, I'm going to keep the unit system as kilonewton and meter for length. So once I click on OK, you are inside Midas SOILWORKS, and now you can do the modeling in Midas SOILWORKS. For doing the modeling, Midas SOILWORKS has a standard set of procedure that you have to follow. So when you go to the foundation tab, you will see that there are different steps that you have to follow to reach to the analysis and report. So the first thing that you have to do is define the ground material property. Then you will define the structure material property, the soil layer information, the foundation type, the PY curve. If you want to define the PY curve manually, you can define the PY curve, the foundation load, the water level, the analysis case, and then you can perform the analysis and obtain the report for the same by defining the ground material properties. For that, I'll go to foundation and I'll select ground material property. I will define the alluvial soil first, so I'm giving it a name alluvial soil. The model type will be sand. So once I select the sand model type, you will see that you have to define the unit weight properties, the unit weight and the saturated unit weight. So I'm going to put in the unit weight and the saturated unit weight. For the sand, I'm going to put the internal friction angle. When you select the model type as sand, you can define the additional parameters too, and for PY analysis especially, you have two different models. So the first model is sandy soil seed ETAL, and the second model is sandy soil API. For the alluvial layer, I'm going to select the sandy API model, and I'm going to define the unit ultimate skin friction as 20, and I'm going to define the unit ultimate bearing capacity as 600. So once I define these parameters, I can click on add, and you can see that the alluvial soil has been defined. Now I'm going to define the weathered soil that I have in my model. The model type will again be sand, and I'm going to define the unit weight, the saturated unit weight, the internal friction angle, which is 26 degrees. This time I'm going to select the material type as sandy soil ETAL, and I'm gonna punch in the properties. The initial horizontal subgrade reaction is 16,000. The unit ultimate skin friction is 30, and the unit ultimate bearing capacity is 4,000. So once I define these parameters, I'll click on add, and you will see that the second material has been defined. Now I'm gonna define the third material as weathered rock. Again, it will have a model type as sand. I'm going to define the unit weight as 20, the saturated unit weight as 22, and the internal friction angle as 28. I'm going to define the initial horizontal subgrade reaction as 43,000 this time. For the weathered rock, the unit ultimate skin friction as 50, and the ultimate bearing capacity per unit as 6,000. Finally, I'm going to define the soft rock that I have in my model, so I'll give the name soft rock. I'm going to select the soft rock model type. I'm going to define the different parameters for the soft rock. So I'm going to define the unit weight as 23, the saturated unit weight as 25, the cohesion as 3000. It's a rock, so the cohesion will be very high. The internal friction angle as 35 degrees. The additional parameters I'm going to define is, I'm going to select the material type as weak rock. I'm going to define the initial horizontal subgrade reaction as 140,000. The strain at 50% stress at to be 0.005. The unit ultimate skin friction as 300 and the unit ultimate bearing capacity as 6000, and I'll click on add. So this is how you can define the ground material property in Midas SolidWorks. Now let's go ahead and define the structural bed property. As I said before, we are going to define two different types of pile. So first of all, I'm going to define a pile having the diameter of 1.5 meters. But before I actually define the pile, let me first brief you with the different options that the structural property definition window comes with. So here you can see that the element type can be steel pipe pile, the PHC pile, the cast in place pile, or the user defined pile. So once you select any of these piles, you can define the attributes for that type of pile. You can select any type of standard. So we have different standards. For the North American region, for the American engineers, we have AISC and ASTM code. For the Canadian engineers, we have CISC and CSA code. So once you select the code, you can select the type of pile that you want, and whatever sections that have been predefined in the code, you can select them automatically, and the different attributes associated with that section will be automatically taken by the program from the standard. You can select the material type and you can define the material from the standard itself. So this is how you can define the material and section properties in Midas SolidWorks. So let us go with our plan and let us define the round pile that we have in our model. So I'm going to select the element type as user defined, the standard type as AISC, ASTM, the section type as round. I'm going to define a user defined section. The diameter would be 1.5 meters. So once I define the diameter as 1.5 meter, you can see that the stiffness is automatically calculated, and I will select the material type as concrete, and I'm going to define the concrete material as grade C5000. So once I click on add, you can see that now we have added one type of structural property. Similarly, we are going to add a structural property for a pile having the diameter as 2 meters. So I'm going to select the diameter as 2 meters, and again I can click on add, and you can see that the different diameter piles have been defined. Now the third step is to define the soil layer information. For that, I will go to soil layer information from the foundation menu that we have. You can see that you have broadly two different distinctions. If you want to define the single layer which has the same attributes throughout the layer, you can select single layer. But if the properties of the soil layer varies from one depth to another, you can select the linearly varying layer, and you can define the two ground material properties between which you want the program to interpolate. So for this tutorial, I'm gonna select the single layer. I will define the name of the first layer as alluvial layer. The depth would be 7.7 meters. The second layer would be weathered soil. The depth would be 9.6 meters. The third layer would be weathered rock. The depth would be 12 meters, and the fourth layer would be soft rock, and the depth would be 20 meters. I will assign different ground material properties to different layers. For weathered soil, I'm going to define the ground material property as weathered soil. For weathered rock, I'm going to select the property as weathered rock, and for soft rock, I'm going to select the property as soft rock. Once you define the different layers, please keep in mind that you have to punch on the add modify feature so that the layers are inserted into the model. So this is how you can insert the layers into the model. Now let us talk about the depth of different layers. So you can see that the alluvial layer has a depth of 7.7 meters that you have defined in your model, but the depth of weathered soil is 9.6 meters minus 7.7 meters. How do we get this figure? You can go to soil layer information again, and you can see that whatever depth that we put in here, it is the cumulative depth of different layers. So the depth of weathered soil would be 9.6 minus 7.7 meters would be 1.9 meters. The fourth step would be to define the foundation type. So I'll go to the foundation type, I'll give it a name. So first of all, I'm going to define the foundation type as a 1.5 diameter foundation. I'm going to define the footing that I have in my model. So I'm defining the footing parameters, and I will define the number of rows that I have in my model for the piles in the X and the Y direction. You can also define the left distance, so you can tell the program from where the pile row has to be started, but in this tutorial I'm gonna keep it symmetrical, so I'm gonna define the equal interval as 3.75 meters. Similarly, I'm gonna keep the pile symmetrical about the x-axis, so I'm gonna define an equal interval of 3.75 meters. So this is how the configuration of pile will look like. You can select the origin point as origin, and you can click on add pile. You can define the pile length as 13 meters, and you can click on add piles, and you can see that the piles have been added. So this is the configuration of pile that I want the program to analyze, and this is how I have modeled it. But you would be curious to know that if this is not the type of configuration that you have in your pile, which generally would not be, how do we model that? For that, you can play around with the pile location. You can place them anywhere based on the graphics. If you want to change the coordinates, you can change the coordinates from the coordinates table. So let's say I change the coordinates of this pile from minus 3.75 to minus 2. You can see that the pile distance has been changed. So this is how you can change, you can play around with the different location of the piles. And once you click on add, you will see that the first foundation type has been added, and now we are going to add the second foundation type, and D will be equal to 2. In the name, I'm going to put D equal to 2, and I'm going to define the B as 15, the length as 15, the height I'll keep as 2.5 meters, the pile length I'll keep as 13 meters. In this time, I'm going to select the diameter as 2 meters. Now you will see that the piles are going outside the model. The reason is because we have retained the pile configuration of the previous foundation type that we have defined. So I'm going to select all of them, and I'm going to delete them, and this is how it appears now. So the number of rows in the X direction would be 3, and the number of rows in Y direction would be 3 again. I'm going to select equal interval as 5 meters in both the directions. So this is how the configuration of pile will look like, and I can click on add piles, and you will see that the piles have been added. Again, I'll click on add, and you can see that the type 2 footing has been added. I'm going to talk about the beta angle and the rotation angle, the tip type, the head condition towards the end of the session. So first of all, let's complete this modeling and let's see the results. So after I define the foundation type, I can define the PY curve if I want to manually define the PY curve for different layers. But in this tutorial, I'm not going to define the PY curves manually. Then I'm going to define the foundation load. So for defining the foundation load, first of all, I'll give it a name. Let's say design load. I will give it the different forces, the shear force, the axial force, and the moment. If you want to punch in the moment, you can punch in the moment too. So whatever forces that you are obtaining from the superstructure, you can put in here. And finally, you can define the water level. So I'm gonna select the boundary set as water level, and I'm gonna define the water level below the ground level. So this is how the water level has been defined. Now I can go ahead and define the analysis case. For that, I will click on add, and I will first define the analysis case for D equal to 1.5 meter piles, and I will select the analysis method as PY nonlinear analysis. I will check on the analysis control. The number of load steps would be 10, the maximum number of iterations would be 10, and the number of divisions per pile would be 100. And I'll click on OK, and you can see that I have defined the analysis control data. In the used data in analysis, I'm gonna put the d equal to 1.5 configuration of file, the water level, and the design load. I'll click on OK, and you can see that the analysis case has been defined. Similarly, I'm going to define the analysis case for t equal to 2. I will select the analysis control data, and I will punch in the values that I need for the analysis control data. I'm going to keep it same as the first case that we have defined. This time I'm gonna put the data used as d equal to 2 foundation type, the boundary set as water level, and the load set as design load. So once I click on OK, you can see that the two analysis cases have been defined. Now I can go ahead and save my model, but this thing you should have done earlier. Just save the model before you do the actual modeling, so that whatever you have done is saved. And now you can go ahead and perform the analysis. So once I perform the analysis, you will see that the analysis is being done, and you will obtain the results in a matter of seconds. So let us wait till the analysis is complete, and then we're going to talk about the different analysis results that we can obtain from Midas SolidWorks. So let us recapitulate whatever we have done so far in our model. So first of all, we defined the ground material property, then we defined the structure material property, we defined the section of the pile and the material of the pile. Then we defined the layers, we defined the foundation type, the configuration of the foundation. Then we defined the load and the water level, and then we defined the analysis case to perform the analysis. And then we ran the analysis, and we obtained this screen which shows us the different steps of performing analysis. So I mean, the time of analysis, it usually depends on different steps that you have defined. So we have asked the program to increase the load in a set of 10 different steps, and you can see that the analysis is complete in about 20 seconds. So when the analysis is complete, you can go ahead and see the results. So let us see the results for d equal to 1.5 analysis case. You can obtain the displacement of foundation, you can obtain the pile displacement and member force in each pile. You can see, you can change the pile, and if you want to obtain the results, you can obtain the element forces. If you want to obtain the graphical result, you can see the graphical results on the top, the horizontal displacement versus depth, the moment versus depth, the shear force versus depth, and the ground reaction versus depth. If you want to see the results for different piles, just go ahead and select different piles, and you can obtain the result for different piles. You can obtain the pile maximum displacement and maximum member force. In this table, Midas SolidWorks will list the most severe results for different piles. If the displacements and everything are not in the valid range, then you can go ahead and change your model and obtain the results in the valid range. You can go to pile head displacement and reaction and obtain the pile head displacement and reaction, which is quite crucial for the pile analysis, for the pile design. If it is not in range, then you can go ahead and change the model attributes and perform the analysis again and see what is the different values for pile head displacement and reaction. Similarly, you can obtain the results for the second analysis case that we have here, and basically you can compare between the two cases and you can come out with an optimal solution. So you can define a set of different pile configurations in Midas SolidWorks, and you can perform the analysis on them at the same time, and you can compare between the different results, and you can obtain what is the optimal design for you. Now let us talk about the foundation type that I said before. So for showing you the beta angle and the rotation, let me first talk about these. So the beta angle is used for define the bettering in the pile. So if I define a beta angle of 15, you can see that the 1 pile has been bettered. And I can also define the tip type support, whatever support that I have on the tip, whether it's a free end, the hinge support, or the fixed end, and whatever head conditions that I have in my pile. So it can be either fixed, it can be hinge supported, it can be elastically restrained. If it is elastically restrained, you can punch in the coefficient of spring rotational constant. If you have eccentricity in the x or y direction for the footing, you can punch in the eccentricity distance here. Now let me talk about how you can use the rotational angle. For using the rotational angle, we'll have to define an H file. So first of all, I'm gonna go to structural property and I'm gonna define an H file. So I will select the shape, the element type as user defined file, the standard as AISC standard. I will use an H file, and I will use any standard file that I have in the AISC standards. I'll click on add and you'll see that the H file has been defined. Now I'll go to the foundation type and I'll select any of the foundation and I'll assign it the H file attributes, and this is how the H file will look like. I zoomed in at this location. So let's say you want to rotate the cross section of the pile. You can use the rotation angle. So when I define the rotation angle as 45, you can see that the cross section of pile has been changed. So this is how you can play around with different modeling features of Midas SolidWorks, and you can create your model very easily in Midas SolidWorks. So that was all about I wanted to talk about today. If you have any question, you can send us the question as midasoft@midasuser.com. Have a good day, guys.